Hello, today I'm going to go over permafrost and climate change lecture. So we've been talking about climate change and different aspects of climate change. Today we're going to look at permafrost, which is frozen ground. Okay, so we'll get a little bit more specific here in a moment. We see a map here. The North Pole is right in the center. Here's the United States. Here's Russia. Permafrost is a layer of soil that stays frozen all year long. Now, it's important to note, actually, for permafrost to be categorized as permafrost, it actually has to stay frozen for multiple years in a row. And some can have been frozen for thousands of years. We can see from the map that permafrost can be found over large areas around the North Pole. So all of these areas that you see shaded in are permafrost. Huge, huge regions. Permafrost can be a continuous layer or broken into pieces. We see that here. We see either big chunks like that take up whole layers of the soil, or smaller pieces that are kind of broken up and discontinuous. The thickness of a layer of permafrost can vary from a few feet to just under a mile. So the permafrost might be just under the soil a little bit where it's frozen ground, or as deep as a mile. And obviously that stuff has been frozen for tens of thousands of years. We know that the atmosphere has warmed over the last 150 years due to human-caused climate change. This is a map showing increases in temperature anomalies in the atmosphere. And this is more recently in 2022. But you see some hot spots here where it's more warming than normal or than other places. This is where it's warmed the most. Most of the warming has occurred at the poles, so the North and South Pole, right? They've actually increased their temperature faster. As temperatures at the poles increase, more of the permafrost near the surface starts to melt. This exposes organic matter and trapped pockets of gas. So when it was locked when the permafrost was frozen and locked in ice, no bacteria were breaking down organic matter. But as it thaws, as it becomes unfrozen, all of this material will get exposed and is being exposed. All right. This image here actually is kind of recent. They've been finding these craters in Siberia, Russia, where large pockets of methane gas exploded. And this is actually a crater from an explosion, not a sinkhole where it just fell in, but an actual explosion caused these craters from a buildup of methane gas. As permafrost melts, large pockets of trapped methane gas can be released into the atmosphere. Exposed organic matter is also broken down and releases CO2. All right, final thing here. So we've got some of the greenhouse gases, the actual molecules there. CO2 and methane are greenhouse gases that increase the temperature of the atmosphere, thus further melting more permafrost. So we have another positive feedback loop. The warmer it gets, more permafrost melts, which causes more warming, which means more permafrost melts. A positive feedback loop. All right, thank you very much.